I can't imagine Megan saying a cuss word, so just that just doesn't seem like something she would do.
No, she actually swears a lot. It's crazy.
Whoa!
Yeah.
At you?
Used to.
Oh, okay.
What did you say? Wait, did this get exposed?
I'm not sure.
Can we do 33 first?
33. Okay. Gotta get low, 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 low. You got them apple bottom jeans, boots with the fur. What? I don't think that will be the song of the day.
Are you allowed to play music?
Allowed to play what?
Like after the jeans?
I mean, you can play anything once.
Yeah, that's homecoming. Of course you can play it.
All right, 33.
You should play California Girls.
Oh,
Damn.
So, I've got rate equals negative change in NaCl over triangle T. The decomposition of nitrosyl chloride was studied. I have this. What is the rate law?
H-Dog,
Yes.
can I go get my book?
Yes.
Bro.
Go grab it. So, did what? Risk it for the biscuit. So if you choose two experiments, let's say we use, I don't know, 2 and 3. How'd you guys do this? Did you graph it or did you?
I used to.
You can't graph this one, right? So if you use experiments 2 and 3, so here would be A, I would have 2.66 times 10 to the 4th is equal to K, right? Times 2.0 times 10 to the 16th to the N.
You just use X, it doesn't have to be N.
Doesn't matter. Doesn't matter. Over 6.64 times 10 to the 3rd, because I want the smaller one on the bottom, is equal to K times 1.0 times 10 to the 16th to the N. So if I divide those, K's gone.
Wait,
What?
what, is this 2 over 3 or 3 over 2?
What?
Is this reaction 2 divided
This
by...
was reaction 3. Or this is 2 over 3.
Okay, thank you.
Yeah, this is 2 over 3. So this ends up being 4, because this divided by that is 4, is equal to 2 to the N. Are you guys okay with that?
Yep.
4 equals 2 to the N. So therefore, N equals 2. So it is second order, right? So it is second order. And the rate law is going to be rate equals concentration of NOCl to the second.
Should there be a K?
Yeah. there's a K. Forgot my rate constant. So that's A. B. Calculate the rate constant. So now you've got to sub in one of your trials. So I always just do trial 1. So rate of trial 1 is 5.98 times 10 to the 4th. I'm going to do my units later. I'm going to do my units later.
Are you okay with us doing the units later on the test as well?
Yeah. I think it's just easier to do the units as a
How
separate
did
step.
you get the 4 equals 2 at the top?
Here? Because
Yes,
this
right.
divided by this is 4,
Okay.
and this divided by this is 2.
You still got the exponents. Okay.
Right? Yes?
Yeah, I think so.
You guys, everyone else okay with that? Okay, sweet. So 5.98 times 10 to the 4th is equal to K times 3.0 times 10 to the 16th. So you're going to solve for that. In K, you end up with 6.6 times 10 to the negative 29th. Oh, squared. Negative 29th. Now, if I do my units separate,
I hate the units on these things.
I have on this one, I have molecules, right? over centimeters cubed times seconds. Agreed?
On the left.
On the left. That's equal to K, which we don't care about. Times the units on this other one is molecules over centimeters cubed. Times molecules over centimeters cubed. But that's going to be molecules.
Square.
This whole thing is going to be squared. So I have to divide over, right? So this is really molecules. I'm going to change this to molecules squared over centimeters cubed squared.
Do you want us to show this part out on the test like, of the units, or
How else will you do this?
just no?
Can you do this in your head? I mean,
In a way, you write everything out.
however you need to do it,
Okay.
it's fine with me.
Yeah, I'll-
So I need to divide over. So if I'm dividing by this, I'm actually multiplying by the reciprocal, right? So it's really going to be molecules over centimeters cubed times seconds times centimeters cubed squared over molecules squared. So molecules on the top is gone, leaving me molecules to the first and the bottom. Centimeters cubed on the bottom is gone, leaving me just centimeter to the first on the top. Agreed? So my units end up being centimeters cubed over molecules times seconds. So that needs to go with your rate constant.
This is harder than the actual math.
It is.
It is. The units are the tricky part. So that was B. And then C, calculate the value of the rate constant when concentrations are given in moles per liter.
Is that dimensional analysis?
That's just dimensional analysis. So I'm going to take my 6.6, so here's C. Am I still on the screen? So 6.6 times 10 to the negative 29th. I need units now. So I have my centimeters cubed over molecules times seconds. And I know that there are 1,000 centimeters cubed in a liter. Agreed?
Right, because 1 centimeter cubed is 1 milliliter.
Correct. And I also know that for every 1 mole of anything, I have 6.02 times 10 to the 23rd molecules. So that will count. Molecules is gone. Moles is going to stay. Right? Yes? Centimeters cubed is gone. So that's going to leave me liter moles. And that ends up being 4.0 times 10 to the negative 8 liters over moles times seconds. So you just convert your units so you have moles and liters. You can't get rid of seconds.
Wait, how did you do the units again?
The units?
Yeah.
For what?
No, at B. On B. Oh boy.
On B?
Yeah. Multiply by the reciprocal.
Multiply. So I had this is equal to this, right?
Yeah. Is it molecules?
I have molecules
over
squared over
centimeters
centimeters cubed squared. And then I'm dividing that over, but when I divide it, I'm multiplying by the reciprocal.
Wait, hold up. Wait, so it's K times molecule squared over centimeters
Cubed.
squared?
This whole thing is squared. That whole fraction is
Wait, then
squared.
what's the thing on the right?
I just said molecule squared over centimeter. I just simplified it.
Oh, okay, so it's not being multiplied together.
No.
Okay.
And then I
Cool.
multiply by the reciprocal. Canceled out. So that was 33.
40.
Anything below 40?
Wait, hold up. Can we do 39?
39?
Yeah.
Yeah, we can do 39. All right, can I move my paper up? Okay. 39, I think I got enough room to do it here. On 39, I am given a set of data. Determine the rate law, the integrated rate law, and the value of the rate constant.
Pretty sure this is the one that you have to graph, isn't it?
You gotta graph it.
Uh-oh.
Yes.
Aubrey,
Wait,
get
you
your
do?
calculator out.
Yes.
I didn't do it. I didn't graph it.
You didn't?
Yeah, I didn't.
Why?
Like, I just it's H2O2, and then it like decomposes, right?
Uh-huh.
So I just assumed that it's one H2O2 decomposing, so I just said it was A. Like I just made that like A, and since it's just A on that, and it like decomposes to something, I said it was molecular. So the rate is K times concentration A, and then I just did it from there.
I think that was lucky.
For real?
Because that worked because this was first order.
What if it was second order?
I don't think it would have worked.
For real? Because I did that for like 31 and 32, and I got.
I mean, if you got it, then you got it. 39, you graph it.
Have I just been doing it wrong the whole time?
I don't know. If you're getting the right answer, then you're good. You graph it, and you get the natural log over time, versus time as a straight line.
Yep.
So, this is first order. So, 39, what are they asking me for? So they're asking for the rate law. Okay, so the rate law is going to be rate equals K times the concentration of H2O2. You get K from your slope. K, you should have got 8.34 times 10 to the negative fourth. Yes? The rate law for this from your half sheet.
I got 0.25 instead of.
That's fine. So your rate law should be natural log of the concentration of A is equal to negative KT. Yes, the integrated rate law. Plus natural log of A at 0. Then it's asking me to solve for at 4,000 seconds, right? The units for K? It's going to be whatever. What seconds? Seconds to negative 1, right?
Why isn't it like a weird wonky moles, liters, seconds?
Isn't it moles over liters?
Whenever it's first order, it's always time to the negative 1. I told you that.
Can I write that on a half sheet? Is that cheap?
I don't care.
But
Do we get to use the F sheet?
Yes.
What half
Oh.
sheet?
The half sheet,
What?
Aubrey?
I wasn't there.
Oh my gosh. Yeah, you really need this. Aubrey, you're making me nervous.
I'm making myself nervous.
But Mr. Heller, the units for K on the previous one were like centimeters cubed divided by molecules times seconds, and for this one, it's just seconds to the negative 1.
Yeah,
Why is that?
because first order. This is now integrated rate law. The last one was not integrated.
Oh, integrated makes a difference.
Integrated makes a difference.
Integrated makes a
Yes.
difference.
All right, so I have to figure this out at 4,000 seconds. So I'm going to do the natural log of the concentration of A, which was what I'm solving for, is equal to negative 8.34 times 10 to the negative fourth times 4,000 seconds. This is going to make a lot more sense, Aubrey. Times the natural log of, at time 0, it was 1. What's the natural log of 1? 0. So, the natural log of the concentration of A, well, you end up, do you want me to show me my work?
No.
Okay. You end up getting concentration of A is equal to 0.037 molar. Just make sure that you raise it e to the negative to get rid of the natural log. What?
I got 0.035.
It's fine. Yep. 0.037 molar. That was 39.
Is it negative 8.3?
Negative 8.34 times 10 to the fourth. That's my K. Because I got K up here, and then I have to make it negative in the integrated rate law. So that was
Wait,
39.
How did you get K again? It was,
The slope from the graph.
oh, okay.
I would have graphed that. So I would have got that from my graph.
I wasn't here.
That was probably
And how'd you?
accurate.
And A is just by getting rid of the ln.
To get the solve this,
Yeah.
I would have multiplied those together. That's 0, right?
Yeah.
And then I would have done e to whatever that gave me
Okay.
to get it to my concentration.
Yeah, that makes sense.
Okay. That was 39.
Wait, Half-Life.
39 didn't ask for one.
It did.
No, it didn't.
It did not.
Oh, it didn't. Sorry.
Next one.
I just do them
40.
all. Like, I don't know how to explain them.
40.
Yeah.
Okay.
Well. Yeah.
Number 40.
I want this one to be on the back.
So 40, a chain reaction, a certain reaction, sorry, cannot read. A certain reaction has the following general form. AA goes to BB. A particular temperature and at A naught, 2 times 10 to the second, negative second molar concentration versus time data were collected for this reaction. And a plot of the natural log of time versus time resulted in a straight line with a slope of negative 2.97. Determine the rate law, integrated rate law, and the value of the rate constant. So 40, they're essentially telling me that this is what? It's first order. So they're telling me that this is first order. Agreed? Yes? Which means that rate is going to equal K times the concentration of what? A. Because A is my only reactant. Agreed? Yes?
Little lowercase a, but you're using that just doesn't matter.
What does that do?
The lowercase a, that's the coefficient,
Oh.
For real? Dang.
which we don't know,
Yikes.
right?
That was bad.
We don't know.
That was.
And then they're asking for the integrated rate law.
Yeah.
So natural log of the concentration of A is equal to negative KT plus the
I actually have
concentration
brain
of,
damage.
plus the natural log. Plus the natural log of A at 0. So that's my integrated rate law.
Yeah, it's another.
On 40, they also told me, they gave me the slope, right? So K is going to equal the opposite of that because from the half sheet, slope is the negative K. So K is 2.97 times 10 to the negative second minutes to the negative 1. So that was A. B, half-life. So for a first order reaction, T1 half is equal to 0.693 from the half sheet divided by K.
Is it 2.97 times 10 to the negative?
Second. I'm sorry. Dying just a little bit. Just a little bit. Actually, I was kind of sick on Friday, so it really worked out having a snow day Friday.
I'm so glad we had today.
It was nice. It was nice. So I'm gonna sub in my stuff. So T1 half is going to equal 0.693 divided by 2.97 times 10 to the negative second minutes to the negative first. Do you see how this is going to work out nicely for units? Because minutes to the negative first ends up being minutes.
Wait, how'd you get the 693?
Half sheet.
What?
Constant.
Oh,
So
okay.
that gives me 23.3 minutes. 23.3 minutes for a half-life. And then on C, how much time is required for the concentration of A to go to 2.5 times 10 to the negative third molar? So I would start dividing by 2, right?
Plug it in using the ln equals KT.
You could,
Okay, that's better.
but couldn't I also, on this one, I started out with how much?
2 point, initial was.
I started out with 2
Point oh times 10 to the
e
negative
negative 10, right?
Wait, negative 10.
I'm sorry. Yeah, you're right. 2 e negative 2. Yes? Divided by 2 is 0.01. What am I trying to get it to?
2.50 times 10 to the negative.
Divided by 2.
Oh.
Divided by 2. How many half-lives did that just go through? No, I divided it by 2 3 times. Right?
Yeah.
So I went through 3 half-lives. Yes?
3 times.
So 3 times 23.3 is what?
69.9.
Yeah.
70.9.
That's going to give you 69.9.
How did you know it was 3?
I divided it by 2.
Plug it in.
What?
I just divided it by 2 until I got to the number.
For real?
How
Yes.
do you know if it's like gonna divide?
Wait, so what
how
are
do
you
you know that
dividing by 2?
dividing by 2 enough times is eventually going to lead to the concentration?
How do you know?
I guess if it was like, yeah.
I
guess
mean,
if-
I looked at this and I know that 0.01, I just kind of did that in my head.
Yeah.
Wait, so how did you, wait, so what did you start?
You could have also used the integrated rate law and got the same thing,
I'm doing it.
right?
What are you dividing?
You could have subbed in.
Say my level.
you could have subbed in, for this one, you could have subbed in and figured it out that it was still 70 minutes. Either way, you would have got the same thing.
Oh,
Wait, so what
But I
did
just
you,
think this is easier.
I guess
what did you divide?
I don't see
it
that.
has to like.
I took,
Wait, can you do it?
doing how I did it again.
Yeah, just like
So I started out with, I'll show my work.
a little equation.
So I started out with A naught. A naught was,
2.0 times 7.
Oh, I get it.
I'm going to write it 0.02 molar. I'm taking it out of exponential form, right? So I'm at 0.02 molar. Divided by 2, that gives me 0.01 molar. Divided by 2, second half-life. Half-life. That gave me 0.0005 molar. Divided by 2, that gave me 0.0025 molar, which is the same as 2.5 times 10 to the negative third. So I went through 1, 2, 3 half-lives.
Yeah, it does. It has to have.
So 3 times the half-life I calculated gives me 69.9.
It's never gonna be like. I guess what I was asking. The concentration is never going to like third, right? It's always going to go down by 1/2.
Correct.
Okay, so that's why.
Always goes down by half.
So the 2.5 times 10 times 10 to the third, what like number is that? Like where did that come from?
This,
Yeah.
they gave me that. They said how much time is required for the concentration of A to decrease
Okay.
to that.
It's 2.5 times 10 to the negative third, right?
Yes. So you could have also put that in the integrated rate law either way. I just did it with, I thought that was easier.
Wait, and then how?
So I went through
so
3
since it was
half-lives.
three-
The half-life is 23.3 minutes. 3 times 23.3 is 69.9.
That's good no way.
Joey.
So that was 40. Cool? Did anybody do it like that, or you guys all use the integrated rate law? Yeah. I thought this
I
was
think I
easy.
did it wrong.
Next one.
43.
43?
Yeah.
Okay. All right, 43.
Actually,
40?
I don't need to see 43 out
I do.
because it's literally the same as 40.
I'll still do it if someone wants it. You want it, Maggie? Okay. 43. I'm given a set. Oh, wait, hold on. The decomposition was studied, concentration were collected, and a plot of A versus time resulted in a straight line.
Okay, this was weird. The way they said it. Is it 0 or first?
It says
0, right?
0. Because it's
plot of concentration of A versus time. So that's just A versus time. That's 0 order. Did you guys all turn your labs in?
Yeah.
Okay.
Okay, I see.
So they said concentration of A versus time gave a straight line. So that is 0 order. That's 0 order. So the rate law is going to be rate equals K concentration of C2H5OH. C2.
Nope.
Nope. First order is natural log.
No, I'm saying like the equation that you just wrote.
I am not done.
Just as weird.
Would that not be the rate law?
Can you just write? Can you
Why
just
did
write?
it look first?
What?
What?
Huh?
Can you just write rate equals k?
Yeah.
Well, yeah. So you would really just say
Could you say rate equals?
rate
Yeah,
equals
it's
K.
0.
Are you kidding me right now?
It's the same thing. Yes? So the rate equals K.
The rate equals k.
Yeah, that's
What I
better.
The integrated rate law on this one is concentration of A. What's that?
We get the half sheet on the test.
Yeah.
Okay.
Is negative KT plus concentration of A at 0. So no natural log here, which is nice. What do they ask me to do? The value of the rate constant. Well, the rate constant is same, right? Yes? So the rate constant is also going to be, well, it's still negative K, right?
Yeah, so should we just?
So it's going to be the positive of whatever the slope was. Oh, they gave me the slope, right?
Yeah.
So K equals 4.00 times 10 to the negative fifth mole over liter
Why is it?
times seconds.
Why is it over liters times second? I thought you said with integrated rate law, it's just second.
This is not. This is 0 order. This isn't first order, right? So for zero order, it's going to be concentration, just this divided by this, right? Mole per liter per second.
I despise this to an end.
So don't overthink it. Don't overthink it. Don't get your rate laws confused either, right?
I have the rate laws. It's just
'Kay.
like when we had like the first order, it was just seconds to the negative first.
So that was A. B, if the initial concentration was this, calculate the half-life for the reaction. So on B, I know that T 1/2 from the half sheet is equal to concentration of A naught over 2 times K. I have all of those things, agreed?
The units are.
So T 1/2 is equal to A naught is 1.25 times 10 to the negative second molar, right? Yes? Divided by 2 times 4.00 times 10 to the negative fifth mole, whatever. You know that the units are going to cancel out, right?
No.
They have to,
Oh, yeah, what are you?
because it's
Oh,
going to be
molar
time,
is- yeah, molar.
right?
Uh,
So this is technically going to be mole over liters times seconds, right? Well, when I divide that, multiply by the reciprocal, right?
Right?
So T 1/2, I got 156 seconds.
When do you
Wait,
want
how'd
us
you get A naught?
They gave it to me,
For real?
for real, for real.
When do you want us to include like
Units, and sometimes you say like in the middle of the equation
shoot.
leave out the
You're right.
units, and sometimes you include them.
On these, I'm not going to be grading units in the middle, okay?
you?
Just make sure you have units on the answers.
I've never.
Cool?
Okay, wait. So how many points do we miss hypothetically if we jack up the units?
If you jack up the units,
Okay, let's say we write the units out and like everything is there, but we don't get the correct units in our final answer.
probably one.
Oh,
Yeah, it's not going to be a huge penalty.
I can
Take it.
I can take
Yeah.
the stab.
Yeah.
You
I'll try.
can take it.
I'll try my best.
So that was B.
These are the units are literally harder than that.
Yeah,
The units are probably the hardest part. And then C, how much time is required for whatever for this to decompose. So on C, I'm going to use integrated rate law. Concentration of A equals negative KT plus concentration of A at 0. So my initial concentration of A,
Wouldn't you set the concentration to be 0 on the left?
yes, 0 equals negative 4.00 times 10 to the negative fifth moles over liters times seconds times T is what I'm solving for. That's a T. It's going to be hard to show. How should I show that's a T, not a plus?
Like
Like
a
a
line
little
on the
square.
bottom.
Like a little, like that?
Yeah. Oh, other way. Okay.
That's fine. Plus,
Put it in parentheses.
Oh.
I mean, you guys know. Plus 1.25 times 10 to the negative second. So solve for T. And T, I got 373 seconds. What'd the book get?
315.
Oh, 313. I can't read my own writing. That's my writing. Here's my writing. Do you see how that kind of looks like a 7?
Oh,
Yeah.
I got 313.
sweet.
313 seconds.
46.
Oh.
Wait, why is A? Oh, it's for all. Okay, that makes sense. All right.
Okay. What is Mr. Ruff doing over there? Is he playing Mario Kart?
No way.
Probably, no,
We played it last year. Yeah,
Last
it
year.
was-
Should we investigate?
I came over for that last day.
I
Because he
remember.
told me if I came out and hung out, I would get free pizza.
You did order
So-
a bad
Yeah,
pizza.
free
I remember
pizza.
that.
That was like
I
a
love that
massive,
kind of class. That was a solid class.
massive pizza party.
It was.
Yeah, when Jack would randomly start talking in the middle.
Hello, Mr. Knight. Hello.
What's the units for shut up, Jack?
1H,
Oh, you're like, guys, how many sig?
2 points for having that and that. 1 point, 1 point.
Okay.
1 point, 1 point.
Okay.
3 points because you got to write out all 3 parts.
We're actually stuck.
4 line method, 5 and 5.
We're actually stuck.
Total 25.
We're actually stuck in the
I
middle
love
of
it.
me
picture of it.
I think
Yep.
he's just as confused as I was.
During chem test, Jack will be like, "Hey guys, what are the 3 states
Thank
of
you.
battery?" Shut up.
I just want to make sure we're on the same
What's the
page.
conversion for
Always.
someone to tell me shut up, Jack?
Hey, what's tomorrow's Spirit Day?
There's a.
I forgot.
It's Spirit Week.
Tomorrow's
Today's,
blackout.
What?
Oh, dang it, I go black.
Wait, what is it?
Jag,
Blackout.
you were the wrong
Guys,
day.
I can go blackout again.
Okay.
Yeah, last year in chem test, I literally would just ask
Start
out loud.
talking. Hey guys, how many signics is number 7? Shut up, Jack.
Jag, this judge is about
That's when I
signage.
used to be so concerned about signics. Now I just don't care.
Jack's like, I'll take it.
All right. Sorry, my wife was asking me if she has enough gas to not run out of gas today. So,
I feel like she got like
Oh.
How
'Cause
many
it's cold
signics is
outside.
number 7
and I take care of her.
the test?
So.
What's the conversion? Well, guys, what's the ideal gas law again?
All right. What number are we doing?
Whoa, wait.
46.
Yeah, 46, please.
All right, 46. So 46,
46.
you have to graph it,
Yo!
right? The Zamboni.
Surprise Zamboni.
That is
Oh,
not what
Zamboni.
you said.
Zamboni, not the
That's where
Zambozi.
the-
What's a Zamboni?
I can't talk today.
Yeah, 46.
46, you graph it. And you get a graph of the natural log versus the concentration as a straight line. Therefore, the order
Wait, can you show
is
us?
first order. When you graph it. Have you done any of these, Joey?
Yeah.
You have?
Yes.
Where does it work?
Like back here.
Oh, okay.
I normally do all the redos on a separate sheet of paper because
Okay.
looking over my work is actually just like brain
That's fine.
damage.
That's fine. What's the order? First order. B, the reaction is known to be first order with respect to NO2. Determine the overall rate law and the value of the rate constant. So, that was A. So A was just graph. Yes?
Yes.
For B, I know that my rate is going to equal K times the concentration of NO2 times the concentration of O. Yes?
Because they're both first order individually.
Yeah, they're both first order individually. They're both first order individually. And we got the K from the slope. So what was your slope? What was your K from up here?
It was 100.
Yeah, it was essentially, it was 100. 100 what?
Seconds to the negative first.
Seconds to the negative first.
Okay, got it now.
100 seconds to the negative first. So they're asking me to determine the,
Overall rate constant?
what is the order of reaction with respect to, we already did the oxygen atoms. Determine the overall rate law and the value of the rate constant. So in order to do this, we're basically saying that my 100, so because it's 1 to 1, right? This 100 essentially is my what? That's like my rate, right? So 100 is going to equal K times, what was the initial thing that they gave me on this one?
1.0 times 10 to the 13th.
Right,
Because it said that NO2 is in such large excess. It
Right.
basically times
1.0 times 10 to the 13th. Because they said NO2 was in large excess.
Oh.
So because NO2 is in large excess, its concentration doesn't even change, right? It's constant. This is what I was talking about in the notes. So to solve for the rho K, you divide over, and
How do you know it is? Yeah. Okay, how do you know that you divide the 100 by the 10 to the 13th and not the 10 to the 13th by the 100?
because 100 is my rate.
Okay, and we just.
And I probably should have put units here because that's seconds to the negative first. This is centimeters. What was this one? This was
Molecules per centimeters cubed.
molecules per centimeters cubed. So I'm going to be dividing that, multiplying by the reciprocal. So my K ends up being, I got 1.0 times 10 to the negative 11th centimeters cubed over molecules times seconds. Let me check that with the book. So the book got 1.0, 10 to the 11th. Yep. We get the same thing.
Because the 100 is the rate, that's why that becomes the numerator.
Right.
Okay.
Yep. That was 46. That one's a little, that one's kind of involved. I wouldn't do one like that in the test tomorrow. So tomorrow's test will be very straightforward.
Aubrey's like,
On 48, like on B, like what does it mean by the first 3 half-lives?
Okay, 48B. What are the first 3 half-lives?
Just take the half-life. Half-life.
Yeah, but like what is the answer supposed to be?
Okay. So 48. On B, we know that it's second order, right?
Yeah.
Yes? It's second order. So, in order to get my 1 half-life, I know for a second order reaction, it's equal to 1 over K times the concentration of A naught. So if I'm subbing in here, that's 1 over, from 47, you figured out that K was 10, right?
Yeah.
Times your initial concentration of A naught, so you had to go back to 47, was
0.05.
what?
0.1. Okay, no, it's 0.1.
It was 0.1, right?
Oh.
10 times 0.1. Are they playing Mario Kart? No, it's fine. 10 times 0.1 is what?
It's
1,
1. So it's just
right? So 10. So this equals, wait, did I forget my K? No, that is my K. So my half-life is equal to what? What do you guys get?
1 second.
Wait, why am I confusing myself here? T1 half is 1 over 10, right?
Yeah. That makes sense because the initial one is 0.1 molar, and then at 1 second, if you look at the graphs, it's at 0.5 molar, which helps.
So my half-life
What did
ends
you
up being
get
how long?
1 second.
1 second.
Wait, how'd you get A naught?
How to get what?
How'd you get the 0.1?
The 0.1? Because my initial concentration for A naught was,
I got 0.05 because I thought it was 1
But
over
it
12.
doesn't extrapolate all the way to 0.05. Like it keeps going.
doesn't keep it.
Nope.
No, hold on. I want to explain this the right way. So I have 10 for my K, right?
Yeah.
And I'm figuring out that it's 1 over 10. Oh, on A, you would have figured out that you had 0.01.
Yeah.
You would have got,
0.01.
I'm sorry, you'd have had 0.1 from A.
Right?
Yeah.
Wait.
So on A, you would have solved for 0.01 molar, right?
Yeah. Yeah.
This is hard when we're skipping straight to B because it doesn't make as much sense. So on B, that first half-life is 1 divided by 10 times 0.1 molar.
Which is from 47.
Because you would have to extend the plot. You would have to extend the plot.
Because it's exponential.
Because the y-intercept, if you extended that, it's going to end up being 0.1. That's the only way you get that 0.1, Maggie.
That's
Okay.
weird.
Yeah,
It's
so
a
this
weird.
10, so
That's a weird one because
It is weird.
So it's 0, 10, and this is 10 is the 1 over the concentration.
Correct.
So it is, the concentration has to be 1.
Yes.
Will we have to know how to do that on the test?
No.
That's good.
There'll be no extending the plot on the test.
Appreciate it.
So your first half-life is 1 second. Your second half-life is going to be at
2 seconds.
2 seconds.
And how
And
do
your
you-
third half-life is going to be at 4. Well, you have to solve. Because your second one, it's not just, it's going to be 1 over 10 times
oh,
0.05, right? Because you're dividing.
dividing
So that gives you the 2. And your third is going to be 1 over the 10 times the 0.025 as I'm dividing.
Okay.
And that gives you the 4 seconds. So that got us up to 48. So I will start with 57, 63, 67, 5th period to make sure that we cover all those.
I have a question.
Yes.